Hey guys, today we're going to talk about a little introduction of chemical reactions in stoichiometry. So, fundamental problems in chemistry require a prediction of how many products will be formed from a specific amount of reactants. And another question could be how much reactants do we need if I want a specific amount of products. So, this is the premise for stoichiometry, which is the quantitative study of reactants and products in chemical reactions. We use the mole method. The coefficients in the chemical reactions can be thought of as the number of moles of each substance. That's very important. So the relative number of moles is the same as the relative number of molecules or atoms in a chemical reaction. Just the relative amounts. So it's all ratios. Hydrogen gas, as an example, reacts with oxygen gas to form water. So first we write the balanced chemical equation. I just want to show you there's a bunch of ways to look at this. We can say that two molecules of molecular hydrogen react with molecular oxygen, one molecule of it, to form 2 molecules of water, or we can think of it as 2 moles of hydrogen react with 1 mole of oxygen to form 2 moles of water, or we can say that 2 times Avogadro's amount of particles react with 1 Avogadro's amount of particles to form 2 Avogadro's amount of particles of water. And this is just a little mental picture to show you how it comes together. So what matters is the relative amounts. The relative amounts, it's all ratios. So what does this implicate? Well, it tells us that what we're going to be looking at is a dimensional analysis. So we can say that 1 mole of oxygen is stoichiometrically equivalent to 2 moles of water or 2 moles of hydrogen. You can think of it as a machine with an input and an expected output. So we can write 1 mole of oxygen is stoichiometrically equivalent to 2 moles of water, or 1 mole of oxygen is equivalent to 2 moles of hydrogen, or 2 moles of hydrogen are equal to 2 moles of water. And because these numbers are the same, the only thing that matters is the relative amounts. We can break down the lowest terms and say 1 mole of hydrogen is equivalent to 1 mole of water. This leads to conversion factors. Just like in my videos on dimensional analysis, we can put them in these conversion factors. So I put all the possibilities down, and we use the appropriate one in chemical calculations to determine reaction yields. So let's do an example. 6 moles of oxygen reacts completely with excess hydrogen. How many moles of H2O is produced? Well, we begin with a given value, which is usually extensive, and we choose a conversion factor given to us by the balanced chemical equation. So we want water, how many moles of water, and we are given oxygen. So we're going to pick a conversion factor with oxygen and water, and we want water at the top, so we're going to choose this one right here. So we're going to put a 2-to-1 ratio. So we go 1 mole of oxygen for every 2 moles of water. We just multiply it out and we get 12 moles of H2O. So that's an easy example. We can even go backwards if you wanted to, so it doesn't matter which way you go. You could start with water and get the 6 moles of oxygen. How many moles of H2 is needed to produce 30 moles of H2O? So this is an example of going backwards. So we need a conversion factor with water and hydrogen, and we need hydrogen on top. So we go over here. I'll pick the simple one. We need hydrogen on top. So it's a 1-to-1 ratio. We go 1 mole of H2O, 1 mole of H2. And we just multiply it out and we get 30 moles of H2. Alright, how many H2O molecules can be produced from 3 moles of oxygen? Okay, we use the same conversion factor we did before. In this multi-step, so now we're left with moles of our water. And we want how many particles in 1 mole. So we know that's an Avogadro's amount, or a mole. Just let me multiply it out. And we're left with 3.6132 times 10 to the 24 molecules of water. So what else can we do? Well, we know the relationships between moles and other physical properties such as mass and volume, and therefore we can predict yields from these properties. So remember that the conversion factors work with atoms, molecules, and moles because the balanced chemical equation is in atoms, molecules, and moles. So we need to convert mass to moles because that's the only ratios that work to use our conversion factors. So what do we need to convert mass to moles? Well, we'll need the molar mass. So suppose we have 42 grams of hydrogen. How many grams of water can be produced? And how many grams of O2 will we need? So there's two questions in here, and I've already set up the whole calculation. So 42 grams, we start with what we're given, 42 grams of hydrogen, and we're going to turn it to moles. That's what happens here. So that's the molar mass right here. This is molar mass. And then, now that we're in moles of hydrogen, we want to convert it to moles of H2O, and we know the ratio is 1 to 1, or 2 to 2. And then we just multiply it by the molar mass of water. So 42 grams. We get 375.3 grams of water from 42 grams of hydrogen. But now we want to know how many grams of oxygen did we need to react with the 42 grams of hydrogen. We can even go backwards from the water and go straight to the oxygen, but we're not. So we're just going to use what we're given, 42 grams times 1 over this yields 333.3 grams of oxygen. So with 42 grams of hydrogen gas, we need 333.3 grams of oxygen gas to react with it to form 375.3 grams of water. So a little mental map of what just happened. We went from mass A, or mass of hydrogen, to moles of A and moles of hydrogen. We used our conversion factors, such as the ones on that board, to convert it to moles of B, or water, and then we can use their molar mass of water to convert it to mass B. So for our final check, we're going to see if we are mass balanced. So on the left side and the right side, we should have an equal amount of mass because of the law of conservation of mass. So left side, we start with 42 grams of hydrogen, and we calculated we needed 333.3 grams of oxygen to react. Ooh, that's terrible. We need 333.3 grams of oxygen to react to form 375.3. So that's the whole right side right there. We add this up and we get 375.3. They're mass balanced, so therefore it's all balanced. So that's just an example, some easy introductions of chemical reactions in stoichiometry. In the next video, we will talk about the limited reagent. Thanks.